Hello everybody, welcome into another lesson. So today we are going to talk about the law of cosines. So a couple lessons ago we talked about the law of sines, which were used to solve triangles that were angle side angle, angle angle side, or side side angle. The law of sines only covered those triangles. The law of cosines works for side angle side and side 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 triangles only. Now the first formula you may sort of recognize. You have c squared equals a squared plus b squared minus 2ab cosine of c. You notice the c squared equals a squared plus b squared part. It looks an awful lot like Pythagorean theorem, doesn't it? Well, that's because, in fact, Pythagorean theorem is derived from the law of cosines. Traditionally, in a right triangle, angle C is the right angle, the 90-degree angle. Well, what's the cosine of 90 degrees? That's 0. So, in a right triangle, this whole negative 2ab cosine of C goes away, and you're literally left with c squared equals a squared plus b squared. And you can, just like the law of sines, you can use a law of cosines on a right triangle, but it's often doing more work than you need to do. The law of cosines covers all triangles, even oblique triangles, of the type of side angle side and side side side. Now, you also have two other versions of the law of cosines. You have a squared equals b squared plus c squared minus 2bc cosine of a. Then you have b squared equals a squared plus c squared minus 2ac cosine of b. How you can remember this the best way is on the left side of the equation is that your angle is going to be the cosine of that angle corresponding to that side, and then you'll have the 2ab of all the other sides on the right hand side. That's probably the best way to remember it. So let's go ahead now and let's get into some examples. So let's see what we got for a first example. We have that angle A is 50 degrees. We have that side B has a length of 15. And then we have that side C has a length of 30. So we're definitely going to stick with side angle side triangles for a few exercises. So as you see, you have a side angle side triangle. So you were given sides B and C and given angle A. So we need to use the appropriate formula. Since we were given angle A, that means we need to start out by solving for A squared. So we can use A squared equals that b squared, which would be 15 squared, plus c squared, which would be that 30 squared, minus 2 times side b, which is 15, times side c, which is 30, times the cosine of 50 degrees, which would be the angle A. Alright, so there's for that. Now A squared is going to equal 225 plus 900. Alright, 2 times 15 is 30 times 30, so that'd be minus 900 times the cosine of 50 degrees. So we're going to try to find a 2 decimal place approximation for side A. And much like with the law of sines, this is often going to involve, this will heavily involve decimal place approximations. So let's take 900 times the cosine of 50 degrees Alright, so let's see. Take 900 minus that answer. Then add 225 to that. Now take the square root of all that. To 2 decimal places, side A is approximately equal to 23.38. So we found side A to have a length of approximately 23.38 units. Well, we found the missing side, but what about the other two angles? Well, take your pick. You can either solve for angle B and then use the difference of 180 plus A plus B to solve for angle C, or you could solve for angle C and find B. It really doesn't matter. As for me, I think we should go in alphabetical order. So we now need to find angle B. Angle B is involved in the B squared equals A squared plus C squared minus 2AC cosine of B. But we do know side B, that's 15, so we could say 15 squared is equal to that A squared, so that would be 23.38 squared plus the C squared, which is 30 squared, minus then we're going to do 2 times side A, which is 23.38, times side C, which is 30. Then we'll do that times the cosine of B. So what's going to end up happening is here we got to solve for angle B, which will set up an inverse cosine problem. So this would turn into 225 is equal to that 23.38 squared. I'd rather not round yet. I don't know why I have 30 to the 0. That doesn't make any sense. Plus 900. Then minus, let's see, that would be minus 60 times 23.38 times the cosine of B. Alright, so what we're going to have now is, I guess we're going to have to kind of round this, unfortunately, in order to be able to make sense of this. Let's take 23.38 to the second power. To 2 decimal places, you get approximately 546.62. So this would mean 225 equals, or is approximately equal to 546.62 plus 900 minus, let's take 60 times 23.38. So that'd be minus 1,402.8 cosine of B. So now let's see, this would leave negative 1402.8 cosine of B would equal the other side. So let's go ahead and do 225 minus 546.62 minus 900. You should get about negative 1,221.62, which then means that the cosine of B is going to actually equal positive 1,221.62 all over 1,402.8. And we know we're going to we have a positive, so we're going to get a first quadrant angle. So let's figure out the measure of angle B. And I should specify with the law of cosines, for whether it's side angle side or side side side, there's only one triangle possible. unlike the law of sines, where if you had the side-side angle, you could have no triangle, one triangle, or two triangles. Law of cosines entirely is only one possible triangle. So let's find the cosine inverse of don't know that I need to do that. So for an angle to 2 decimal places, angle B is approximately equal to 29.44 degrees. Alright, so there's your angle B. We know A and B now. We can easily solve for C. So that means the measure of angle C is going to equal 180 degrees minus 50 degrees minus 29.44 degrees, which now we should be able to get a 2 decimal place approximation for angle C. So 180 minus 50 minus another 29.44 gives you angle C is approximately equal to 100.56 degrees. So when you use the law of cosines, you have to do it twice for a triangle. And then you can figure out the third angle just by subtracting the sum of the other two angles from 180. But yeah, that's the first example of the law of cosines. You get side A is approximately 23.38 units, angle B is approximately 29.44 degrees, angle C is approximately 100.56 degrees. Alright, let's do 2 more side angle sides, then we'll move on to side, side, side. Definitely not going to be 50 this time. Alright, so this will be side B, this will be side C. Let's see what we're given this time. Angle C has a measure of 108 degrees. Side A has a length of 10. Side B has a length of 7. Alright, so yes, we have another side angle side triangle. We know angle A, we know angle C, but we don't know angles B or A. We know sides A and B, we don't know side C. I'm going to say let's go for side C first. So that means then C squared equals our A squared, which would be 10 squared, plus the B squared, which is 7 squared, then minus 2 times side A, which is going to be 10, times side B, which is 7, times that cosine of angle C, which is the cosine of 108 degrees. So then C squared should end up equaling 100 plus 49 minus 140 times the cosine of 108 degrees. Now we should be able to get a 2 decimal place approximation for side C. So this won't be too bad at all. Then I just take the square root of that side. So for side C, I should get an approximate length of 2 decimal places of 13.87 units. So now we found side C to be approximately 13.87 units. Okay, well, we still have to deal with the angles. I'm actually going to suggest we go in alphabetical order, go for angle A. You can go for B, but I like to go in alphabetical order. Since we need to solve for angle A, we need to deal with the A squared equals B squared plus C squared minus 2B cosine of A. So we know side A itself is 10, so that would be 10 squared would equal B squared, which is 7 squared, plus side C, which turned out to be about 13.87, so that would be to the second power, minus 2 times side B, which is 7, times side C, which is approximately 13.87, all that times the cosine of A. And yes, we'll have to use an inverse cosine to solve for angle A. So this would end up being 100 equals 49 plus, let's figure out what 13.87 squared is. That's about 192.38. And then, let's see here. So 2 times 7 times 13.87 gives you about, let's see, that'd be about minus 194.18 times the cosine of A. So this means now that negative 194.18 times the cosine of A is going to equal the difference of everything else. So 100 minus 49 minus another 192.38, so that should equal negative 141.38. So then that means the cosine of A should equal positive 141.38 over 194.18. And now we should be able to get a 2 decimal place approximation for angle A. Alright, so to 2 decimal places, angle A is approximately 43.27 degrees. So you get that angle A is approximately equal to 43.27 degrees. Now we can easily find B. Just take the difference of the other 2 angles from 180. So the measure of angle B would equal 180 degrees minus 43.27 degrees minus 108 degrees. And then we should be able to get a 2 decimal place approximation for B. Alright, so 180 minus 43.27 minus 108, you get that angle B is approximately 28.73 degrees. So after applying the law of cosines, you get that side C is approximately 13.87 units, angle A is approximately 43.27 degrees, angle B is approximately equal to 28.73 degrees. I got one more side angle side, and then we're going to do a couple side. Alright, what do we got this time? Angle B is going to be 8 degrees in 15 minutes. Side A has a length of 26. Side C has a length of 18. Alright, so we know angle B. We know sides A and C, so that means we need to find side B first. And since we know angle B, we need to use this formula, the B squared equals A squared plus C squared minus 2AC cosine of B. Again, which formula you use depends on which angles and sides you're given. So let's do this formula then. So we'll take B squared equals the A squared, which is 26 squared, plus that C squared, which is 18 squared, minus 2 times side A, which is 26, times side C, which is 18, times the cosine. So 8 degrees in 15 minutes. 15 minutes is a quarter of a degree, so that would be the cosine of 8.25 degrees. Alright, so then B squared would equal, let's just figure out what the heck all these values are. So 26 to the second is 676. Now, I want to say 18 squared is 324. Yes, it is. Wow. Plus 324 minus, alright, all that mess there. So 2 times 26 times 18. That'd be minus 936 times the cosine of 8.25 degrees. Now we should be able to get a 2 decimal place approximation. So let's solve for all this. So 936 times the cosine of 8.25. Alright, so then take 324 minus that, add another 676 to that, and then take the square root of that. So you should end up getting side B is approximately equal to 8.58 units after applying the law of cosines. So angle B is approximately 8.58 units. Now we still have 2 other angles we got to solve for. Personally, I'm going to vote we solve for angle A. Go in alphabetical order. So since we need to find angle A, let's use the formula that involves angle A. So that'll be our A squared, which would be in this case 26 squared, equals B squared, which would turn out to be 8.58 squared, plus the C squared, which is 18 squared, minus 2 times B, so that'd be 2 times 8.58, times side C, which was 18, all that times the cosine of A. And yes, we're going to end up having another inverse cosine. So that'd be 676 equals, well, what the heck is 8.58 squared? I'm not exactly sure. It's about 73.62. So why am I doing that? Okay, 73.62 plus 324 minus, now let's figure out that this mess over here. 2 times 8.58 times another 18 gives you about 308.88 times the cosine of A. So this means negative 308.88 cosine of A is going to equal the difference of everything else. And something very interesting is about to happen. Equals positive 278.38. So that means the cosine of A equals negative 278.38 over 308.88. Well, since you're going to take the inverse cosine of a negative number, that means that angle A should end up being a second quadrant angle. So let's find the value to 2 decimal places for angle A. So yes, if you get a negative number on the right hand side, that's okay, because the domain of, the range of the cosine, or it's the domain is still negative. You'll get a range of a second quadrant angle. It goes from 0 to 180, so we know we're good there. So negative 278.38 divided by 308.88. Now take the cosine inverse of that mess. You should get an angle of approximately 154.32 degrees. So angle A is approximately equal to 154.32 degrees. Now we can easily solve for C. The measure of angle C would equal 180 degrees minus that 154.32 degrees minus that 8.25 degrees. So now we should get a 2 decimal place approximation for angle C. So 180 minus 154.32 minus 8.25 to 2 decimal places, angle C is approximately 17.43 degrees. So applying the law of cosines, you get that side B is approximately 8.58 units. Angle A is approximately 154.32 degrees, and angle C is approximately 17.43 degrees. Alright, so those are the side triangles. Let's go on to some side triangles. And those actually are not as bad as you think. Alright, so here's side A, here's side C. Let's see what we're given here. So side A has a length of 9. Side B has a length of 12. Side C has a length of 15. I want to say that's going to end up being a right triangle, but let's prove it. So, you know your 3 sides this time, you don't know any of the angles. Well, I'm going to do an unconventional thing. We're going to go for angle C first. So since we want to solve for angle C, it's going to have to be the formula involving angle C. So that would be C squared equals A squared plus B squared minus 2AB cosine of C. Okay. So C squared, that's going to be 15 squared equals our a squared, which would be 9 squared, plus the b squared, which is 12 squared, minus 2 times our a of 9 times our b of 12 times the cosine of c, which we don't know just yet. Okay, so that means 225 equals 81 plus 144. So 9 times 12 is 108 times 2. That'd be minus 216 times the cosine of c. So that actually means that negative 216 cosine of c, well, what do you know? That's actually going to equal 0. So that means the cosine of c equals 0. If you take the inverse cosine, you'll get that c equals exactly 90 degrees. So this actually does turn out to be a right triangle, but we still have to solve for the other two angles. So angle C is exactly 90 degrees. We still need to find angles A and B. Well, let's go for angle A. Since we want to solve for angle A, let's use this formula. So that would mean that our A squared, which is going to be the 9 squared, equals B squared, which is 12 squared, plus the C squared, which is going to be 15 squared, minus 2 times side B, which is 12, times side C, which is 15, times the cosine of A. So this means 81 equals 144 plus 225 minus 360 times the cosine of A. So then negative 360 times the cosine of A is going to equal the difference of all that. (81) minus 144 minus 225 gives you negative 288. So that means the cosine of A itself equals positive 288 over 360. Now we should be able to get a 2 decimal place approximation for angle A. So 288 divided by 360. Now take the cosine inverse of that. To 2 decimal places, you get that angle A is approximately 36.87 units. And then we can easily solve for angle B. So the measure of angle B equals that 180 degrees minus the 36.87 degrees minus 90 degrees, which let's go ahead and find that. (180) minus 36.87 minus a whole 90, yep, you get that angle B is approximately equal to 53.13 degrees. So just like with side angle side, you have to apply the law of cosines twice to find 2 of the angles, and then you could just easily find the third angle by just taking all the difference from 180 of the sum of the angles. So you get that angle C was exactly 90 degrees, making this a right triangle. Angle A is approximately 36.87 degrees. Angle B is approximately 53.13 degrees. Now let's do one more side. In my opinion, these are kind of easier in a way than the side angle side, but you may think the opposite, and that's okay. B, and then this is side C. Okay. One more side, then we'll be done with the lesson. So what do we got here? Side A is 45. Side B is 30. What's side C? Side C is going to be 72. Alright, so let's go ahead and solve this one. So we know all the sides, but we don't know any of the angles. Well, that's okay. Why don't we go for side C, angle C again. So we want to find angle C, so we're going to have to use this formula. So that means C squared, which in this case is 72 squared, equals A squared, which is 45 squared, plus that B squared, which is 30 squared, minus 2 times side A times side C, times side B, which is 30, times the cosine of C, which we don't know just yet. So now let's figure out this whole mess. Alright, so 72 to the second is 5,184. Let's figure out 45 squared. Is that 2025? No, that's not what I wanted. It is 2025, yep. That was just last year. I know 30 squared's 900. Okay. Minus all the rest of that, so 90 times, that'd be minus 2700 cosine of C. So now let's just figure out the difference of all this. So that would mean negative 2700 cosine of C is equal to the difference of everything else. So 5184 minus 2025 minus another 900 gives you 2,256. So that actually means then that the cosine of C itself equals negative 2,256 all over 2,700. Well, since we're going to take the inverse cosine of a negative number, we're going to get a second quadrant angle. So let's get a 2 decimal place approximation for the angle. To 2 decimal places, angle C is approximately 146.67 degrees. So we just found angle C to be approximately 146.67 degrees. Alright, well, let's go for side A. Let's go for angle A now. So if we want to... No, actually, let's go for angle B. This one's been kind of neglected today. So if we want to find angle B, let's use this formula. So that means B squared, which is 30 squared, is going to equal that A squared, which is 45 squared, plus the C squared, which is 72 squared, minus 2 times side A, which is 45, times side C, which is 72, all that times the cosine of B, and yes, we'll have another inverse cosine to solve. So this means 900 would end up equaling 2025 plus 5,184 minus that whole mess. Alright, so 2 times 45 times 72, that would be minus 6,480 times the cosine of b. So now negative 6,480 times the cosine of b would equal the difference of everything else. So 900 minus 2025 minus 5184 gives you negative 6,309. So then the cosine of b itself would equal positive 6,309 all over 6,480. So now we should be able to find a 2 decimal place approximation for angle B by taking the inverse cosine of the right side. You get an angle measure of approximately 13.19 degrees for angle B. So now you know angles A and B. Let's go ahead and find, now you know angles B and C rather. Let's go ahead and find angle A. So the measure of angle A equals that 180 degrees minus 13.19 degrees minus 146.67 degrees. So now we should be able to get a 2 decimal place approximation for angle A. (180 minus 13.19 minus 146.67 will give you an angle measure of approximately 20.14 degrees. So using the law of cosines, we ended up getting that angle C was approximately 146.67 degrees. Angle B is approximately 13.19 degrees, and angle A is approximately 20.14 degrees. Alright, so that's it for this lesson. Next lesson, we're actually going to use another formula for finding the area of an oblique triangle, which only applies to side-side-side triangles, called Heron's formula. We will talk about that. So I hope everyone has a great day. Take care.